So, long division. What is quotient, remainder, divisor, or dividend? Give me definitions of any one of the four from whatever it is that you remember. Marissa.
Quotient is the result of a division problem.
Okay, that's the result of a division problem. Okay? Somebody else, one of the other three. Give me what you remember. Anything. Simon.
Remainder is what's left over after dividing.
Okay. What is left over at the end, right? Okay. What's the divisor or the dividend? I'll give you a hint. 23 is one of them and 605 is the other, but which is which? Take a guess. What's divisor? Which one's the divisor and which one's the dividend?
23 is the divisor.
Yes, yes. So the divisor is the number you are dividing by. And therefore the dividend, who can put that into words? Somebody new. Dividend, how would I put that into words? Paul, Catherine, Aaron? Dividend. How would you say, what is the 605? How would you put that in words?
The number that's being divided.
Good. The number that is being divided. Okay, so what we're going to do today is we're going to talk about long division with the purpose of launching us into dividing a polynomial. Now, I realize that many of you know how to do long division. Some of you may not remember. Some of you, it may have been 5, 10 years since you did long division. I'm not sure. And so our purpose in doing long division at the beginning is not necessarily to say, hey, what's 605 divided by 23? The purpose is to say, what are the steps that we're doing when we're doing long division? And then we're going to take those steps and apply them, Abby, to our polynomials. And the steps are consistent. And so, what is the first question that you ask when you're looking at this 23 divided into 605? The very first question that you think. Aaron.
How many times does 23 go into 605?
Okay, that's the big picture. So then let's break it down even further. That's good. So what do you do even further? Marissa?
First, you would look at the first number and say, what 23 go into 6, which it wouldn't, so you go to this next number, which is 0. So
okay, so does 23 go into 6? The answer is no. So now does 23 go into 60? Could you even go further to kind of think, does 2 go into 6? In that way of thinking, you know, to some degree. So does 23 go into 6? No. Does 23 go into 60? Yes. How many times? Twice. So we put a 2 up here. Do you agree? Now I put it above the 0. What is the next step?
Multiply 23 by 2.
Okay, and it's interesting, Paul, how you said multiply 23 by 2. You just didn't say multiply the 2 by the 3, or by the 2, but you said the 23. You said both digits. And I know that sounds really trivial, but later that's going to make a difference because we want to make sure we multiply not only the 2 of the 20, but also the 3 of the 23. So, 2 times 23 obviously is 46. I write down the 46. What's next?
And you subtract.
Okay, so we put a line. Now this is going to sound really strange. 6 minus 4 and 0 minus 6. We have to borrow, right? So 10 minus 6 is a 4. The 6 became a 5, and 5 minus 4 is a 1. Good morning. All right, next step. Bring down the what?
5.
I used to do this when I was in grade school. I'd do a little dotted line with an arrow, and I'd bring down the 5. And now we ask the question again, back to Marissa's question. Does 23 go into 145? Obviously the answer is yes. The question is how many times? Does it go in 7 times or 6? 6, okay. So we put down the 6. 6 times 3 is 18, carry the 1. 6 times 2 is 12, plus 1 is 138. We go through and subtract again. And 145 minus 138, would we agree, is 7? And 7 is our remainder. And back in 5th grade, we would do R7. But we're not going to do that here, Simon. What we're going to do is we're going to say this is really, the answer is 26 and 7/23. Because that's really what we have left over. If you multiply 26 and 7/23 by 23, you would get 605. Does that ring a bell? Those steps. All right, let's take that and go to a different way to write it. It says divide 244 by 7. This could also be written like this. I can't remember the last time I actually wrote a division sign, but it could have been written like that. Or it could have been written, obviously, with long division. Let's see how fast we can do this. Does 7 go into 24?
Yeah.
3 times. 21. Left over 34. Does 7 go into 34?
Because it says 28.
Okay, so 4 times, so 28. Left over is 6. So 34 and 6/7. Did I do it right? So we're not going to put R6. That's my point. We're not going to do this R6 thing. And we're not going to go decimals. Okay, we're just going to stop at 6/7. All right, moving over. X divided into 3x cubed. Well, x times what is 3x cubed? 3x squared. Let's see. Is 3x squared times x 3x cubed? Go through and do what? Subtract. What's left? 0. So does it go in evenly? All right. That's still long division, isn't it? We're still asking the same questions. It's just a case of thinking through it with variables. So we've got 3 different scenarios: numbers, written, and then variables with a term. Okay, let's go from there. Let's slide down. Now, divide this polynomial by this other polynomial. Let's review for our quiz tomorrow. X squared plus 2x minus 30. What is the degree of the whole polynomial? Raise your hand if you know. Okay, this should be an easy question tomorrow. What is the degree, Max? Quadratic, because the highest exponent is a 2. And that's a trinomial, yes? Now, the x minus 5, let's review there. What's the degree of the x minus 5? The degree is 1. Remember what that word is called? Linear. And what kind of linear polynomial is this? This is a linear, good, Aaron, a linear binomial. So what we're going to do is I'm going to have you move down maybe in 1/2 inch to 1 inch, and we're going to make a long division symbol. X squared plus 2x minus 30 is going to go inside there. Remember, that's the dividend. And on the outside, we're going to put x minus 5. All right. Our first question that we're going to ask ourselves is x times what is x squared? What's the answer? X times what is x squared? X. We're going to put an x up here. Now we multiply. X times x is x squared. And Paul, this is like the 23. We don't just multiply by the x, we're also going to multiply it by the minus 5. So x times minus 5 is minus 5x. Now notice I put it under the linear term, under the x term. Now if we go back up to the top, the next thing we did was we subtracted. Now I would suggest you change colors here to something else. I'm going to go to green. And I'm going to subtract each one. So I'm going to put a minus sign there, and I'm going to put a plus sign here. I'm going to change my minus to a plus, because minus a minus, Simon, is a plus. Now we look at them vertically. I'm going to go back to red. x squared and negative x squared is nothing. 2x and 5x is 7x. And we bring down the 30. Now we start over again. Marissa, Cole, or Catherine. X times what is 7x? 7. I need a plus or a minus, please. Okay, plus 7. So we multiply 7x, 7 times 5, negative 35. Go through and subtract. Subtract the first one and the second one. It became a plus again. So we go through now, and 7x minus 7x is 0. Negative 30 plus 35 is a what? 5. And so that's our remainder. And so what we do is we do plus 5 over x minus 5. And that's our answer. Did it go in evenly? No.
Could you simplify the 5 over x minus 5?
No, you may not. It's a good question. If you remember back, the only time you can simplify those kind of numbers is if it has 3 numbers. So if we had 5 over 20x minus 5, then we could, because you look at this number, and that number, and you could divide all of those by 5. So that would become 1 over 4x minus 1. But because you can't divide the x by 5, not allowed to. Here.
Where'd you get the blue negative 7x plus 34?
I got that from this positive 7 times the x minus 5 is 7x minus 35. Notice the blue is in minus, and then the green changes the sign. Remember, I have to go through and subtract, right? If we go back up to our top, we subtracted 46. We didn't just subtract the 4, we also subtracted the 6. I know that sounds trivial. So we not only have to subtract the 7x, we're also subtracting the negative 35, which makes it a positive. Okay, any questions so far? Do you remember doing this in Algebra 1? Okay, it was a long time ago. All right, let's look down. We're going to do a couple little examples just to help us practice. So, 2x cubed minus 3x squared minus 18x minus 8 divided by x minus 4. Tell me what you're thinking here. Haley, Noah. X times what is 2x cubed? 2x squared. There we go. 2x squared. Now we multiply. Mr. Sharkey, can you multiply for me? 2x squared times x and 2x squared times negative 4.
2x cubed minus 8x squared.
Good. All right, I'm going to switch to red and go through and subtract. And notice, Haley, I'm going to change this to a minus, and I'm going to change that other minus to a plus. Is it easier to see when it's red versus the green, hopefully?
You always put the sign in that stuff.
If you didn't, what would happen?
Well, remember, if you didn't, we go back to the 46. Would it make sense to subtract the 4 and not subtract the 6? We have to subtract both, correct? And over here, we not only subtracted the 1 of 138, we also subtracted the 3 and the 8. Okay, so the 1, the 3, and the 8 are like 3 different terms. So down here, it wouldn't make sense if we only subtracted the 2x cubed and didn't deal with the 8x squared. So you have to subtract each one. Does that help? You can't just do one and not the other. It's like if I brought cookies and just gave them to that half of the class, but not this half of the class. You guys would be very happy, they'd be very sad. And, that would not be a good thing, because we don't want Simon to be sad. He has enough S's in his name already. So, all right, here we go. No x cubes, 5x squared, minus 18x. Thank you, Sharky and Noah. All right, Una, Kent, Max. What times x is 5x squared?
5.
5.
A 5x.
5x. I need one more thing.
Plus 5.
Thank you. It is very important that we do have a sign up there. Would we agree? All right, so we multiply 5x squared minus 20x. I'm going to switch to red. I subtract there. And notice, Aaron, see this minus 20x? I'm really subtracting it. But what's a minus minus? It becomes a plus. And so I'm going to erase my minus minus and make it a plus. That gives me a result of 2x minus 8. We're almost done. Madeline and Simon and Abby. X times what is 2x? 2. What 2?
Plus 2.
Plus 2. Abby, could you multiply for me? 2 times x minus 4.
2x minus 8.
Okay. Madeline, what's next?
You're gonna switch the signs. It's gonna be negative.
So minus and a plus. And now what? Go through and add them up, right? What's left? Nothing. What does that mean? It's a factor. It goes in evenly, and there's no remainder. All of those things. So we just factored 2x cubed minus 3x squared minus 18x minus 8. And the factors are that and that. Now, you might be able to go further. We're not going to, but you could. So the answer is just what we have up there at the top. Aaron. This 5x here? We were looking at this term right here, and we said x times what is 5x squared. All right? I'm going to erase those so it's not confusing later. Any other questions? All right, let's keep moving down, a little practice. Determine whether x plus 2 is a factor of each polynomial. So this just gives us short little practice to see if this works. X plus 2. Here we go. X times x is x squared. So x times x plus 2 is x squared plus 2x. We haven't done a plus yet. So this is our chance to kind of start off by doing a plus. We go through and subtract. Change that sign, change that sign. The x squareds are gone. That leaves us with 8x plus 16. Now, Aaron, I'm going to kind of have you help me here. We have an 8x at the bottom. We have an x on the top left. X times what is 8x? Did you say 8x?
Yeah.
Okay, let me write that down. What is 8x times x, Aaron?
What?
What is 8x times x?
Yeah.
Isn't that 8x squared?
Oh, yeah.
So let's get rid of this x here, and let's just use an 8. So that's 8x plus 16. We go through and subtract. We get 0. So let's answer the question. Is x plus 2 a factor? Yeah. I'm trying to do it on a very simple problem. You may have been able to look at it and say, yeah, of course it's a factor. Let's look at this next one. X cubed plus 7x squared minus 5x minus 6 divided by x plus 2. All right. Talk to me here. Cole, Kent, my K guys. What goes first? X times what is x cubed?
X squared.
X squared. So x cubed plus 2x squared.
Then minus x cubed, and then that squared.
All right.
So then that will be 5x squared.
Good. Cole, you're up.
It will be 5x.
Good. So 5x squared plus 10x, right? Kent, back to you.
So then would be minus 5x, minus 10x, 5x more than 10x, and that would be 15x negative. And then we bring up
Cole, back to you. Gesundheit.
would it be 15?
15. What 15? Plus 15 or minus 15?
Plus.
So positive 15x times x is 15x. Don't we want this to be identical, Cole?
Yeah.
So let's change that plus to a minus, because we want those to be identical. Otherwise, when we subtract, it's not going to work. And then negative 15 times 2 is negative 30. Go through and change the signs. I get 24. Do you agree?
Yes.
So, what's the question? Is it a factor?
No.
Yeah. Paul, to get back to your other question before, I think it was your question, or maybe it was Ken's. This would be plus 24 over x plus 2. Ken, I think this was your question, wasn't it? So the 24, Ken, and the 2 don't cancel.
Yeah.
Because there would have to be a 4 or a 6 or an 8 on the x.
Could you split the fraction?
No. You can only split a fraction if the numerator has 2 parts, not the denominator. The denominator is combined together. All right. Really short assignment tonight. My anticipation is you're going to finish it probably in class. And I want to be able to stand kind of with you because this has got a lot of little detail. Once again, I tried to help you out a little bit here. So here is the problems at the bottom of your draw board. Hopefully that helps you a little bit. All right, give me a sec here.